Good morning. Welcome. Today we will learn how to find maximum shear force at a section when longer UDL is traversing the girder. So you can see here I have taken a girder AB of span 30 meters. Okay. So our requirement is say at 10 meters from left, what is the maximum shear force that can be developed because of a longer UDL? Let us say the longer UDL value, I'll just write here, let it be 30 kilonewton per meter, okay, is the load value, okay. So a longer UDL is longer than the span AB. That means the span of UDL is more than 30 meters. Okay. So in that case, how do you find maximum shear force? So as you require shear force, first let us draw ILD for shear force at a section. This is first thing that we need to do. Okay. So let me draw the ILD for shear force. So from the previous lectures, you have learned how to plot the ILD for shear force at a section. Okay. So the ILD ordinate value is 0 at A and it will have lesser ordinate towards A and more value towards B, and this you join the 0. So this value is like A by L, that means 10 by 30, A being the span 10 meters where the section is from left, and it is coming to 1 by 3, and this one will be B by L where this is 20 meters. Okay, so A is 10 meters, B is 20 meters. So A means the span AC, B means span BC. Okay. So if you do that, B by L, that means 20 by 30, so which comes to 2 by 3 is the value. Okay. So this ordinate here is 2 by 3. This ordinate here is 1 by 3. Okay. And this is negative shear. It's positive shear. Right. So this you have learned from the earlier lectures. Okay. Now, if you want maximum shear force, okay. So let us say you want maximum negative shear force. First we will calculate maximum negative shear force. Okay. Right. So if I want maximum negative shear force, the UDL position of UDL, how do I place this UDL? Okay, so if this UDL traveling from left to right, okay, so this we call it as a head, right? So head is to occupy just left of C, okay, head of UDL shall be just left of section C, just left of C. So I'll draw that position of UDL with a different color. So now this is UDL position. Okay, so I'll break this here. It shows that the span is still there. Okay, now the value of this UDL is 30 kilonewton per meter. Okay, so why this has to take this position? Because when you want to find the value of a function when there is UDL, you shall see how much area that is occupying the ILD. So this is negative area that is available. You want negative shear force. So place the UDL to occupy maximum negative area. So this is a possibility. Okay. So head should be just left of C. Then only maximum negative shear force develops. Okay. So now the value is shear force value. So by previous lectures you have learned that when there is UDL, the function value is equal to UDL value, load value multiplied by the area of ILD occupied by the UDL, right? So I'll calculate that value. It is half, it's a triangle. So base is 10 meters. Height is the ordinate that we have calculated, that is 1 by 3. So now if you just work out this value, okay, so this is going to be 50 kilonewton. Okay, so this is maximum negative shear force possible in this girder at C for any position of the UDL. Okay, now let us calculate maximum positive shear force. Okay, so for positive shear force, you see that the positive ILD is this one, which is hatched. Okay, so this is positive ILD available. So how do you place the load? That is next thing to do. So now your UDL shall pass through like this and it has to move further, and the tail portion has to come here. This is the tail portion. Okay, now the value is 30, right? So for this position you can see the UDL is occupying the total positive ILD area. Okay, so that is the requirement. Now if I want to shear force at C, which is positive shear force maximum, so it is again load value multiplied by the area of ILD, occupied ILD is half base, height is 2 by 3 is the ordinate that you have already calculated, this height of this triangle. Okay, so now if you work out that, so here 2 goes, okay, so it will be 200 kilonewton. So maximum negative shear force possible at C is 50. Maximum positive shear force possible at C is 200. Okay. So out of these two, which is maximum shear force is the positive value. That is your answer. Okay. So if your question is only to find maximum negative shear force, you can stop your solution with this. Okay. If your question is to find maximum positive shear force, you will be doing this part. And if your question is to find what is the maximum shear force at a particular section, not mentioning whether it is negative or positive, you shall report the answer as 200 by checking both the values. Okay? By intuition or by just looking at this diagram, we definitely know that the positive area is more than the negative area. Okay, so with that, just by physical observation, just by viewing the diagram, you can easily identify that which shear force is going to be the maximum. Okay, so this is the solution, and so you have learned how you can find a shear force value, maximum shear force value at a particular section in a given beam or girder. Thank you.